Hey everyone, welcome back to Web Solutions. Today in this video, we will deep dive into what exactly is Layer 0 and how it's making difference in a Web3 industry. So let's get started. First of all, what is Layer 0? With over $293 million funding, a Layer 0 is an inter-blockchain communication framework where the developers like us can easily build applications that can work and communicate with multiple blockchains like Ethereum, Polygon, Arbitrum simultaneously without any hassle. Okay, so this is one of the first framework which provides services for decentralized applications, which you call dApps, to communicate with other blockchains for free with zero cost. Okay, there is no cost included for developers for to communicate with other blockchains. Okay, so this is one of the first framework which provides the inter-blockchain messaging framework. Okay, as you can see, it's just we'll deep dive into what exactly and how it works though. Okay, there will not be any contracts part here. We'll just deep dive into what exactly is layer zero and how it actually make things happen. Okay, so as you all know, it has over $293 million funding with many big names in the industry. If we scroll down a little bit, as you can see, Binance Labs is there, Avalanche Phantom, Uniswap Labs, Polygon is there, Coinbase Ventures, and many things are there which are funding this protocol for making it happen. As you all know, blockchains are created to be isolated. They don't communicate with other blockchains to make things happen. So usually the liquidations, not the liquidations, the liquidities are splitted in all the blockchains with no single blockchain containing all the liquidity at the same time. Okay, it's all distributed and it's splitted to other blockchains. Layer 0 is a different thing where a developers like us can create a application, basically a decentralized application which works with all other blockchains with layer 0 supports, which are EVM compatible, for having a single liquidity across all the chains, maintaining no splitting of liquidity over there. Okay, so if you want to read the white paper over here, you can just click on here. The white paper will be there, and as you all know, the points are here. You can look at it to the website on the layer0.network. I'm not saying that it's just raised $293 million just in air. Okay, it's here in Crunchbase. It's verified that over 9 funding rounds, it has raised over $293 million for just the cross-chain messaging. Okay, as I said before, this is the first cross-chain messaging framework provided for developers. Okay, so now let us look at how this works. So as you all know, this is a framework, but how exactly it works and how it makes things happen. So let's see it. Okay, so we'll just dive into our snip and sketch. Okay, this is what the basic. Okay, even though if you navigate to the white paper, right, there you will find their the same thing. Here also you will find their white paper along with that how it works. You can go to this as well, but provide an introduction to it. We will deep dive into this in our script and sketch itself. Okay, so this is a chain A. Let's suppose this to be a Ethereum, and let's suppose this to be a Matic. Okay, so what happens is user applications is nothing but our dApps. Okay, we as our dApp creators integrate layer 0 to communicate with other chain which is Matic. Okay, so what happens exactly is these are the numberings to specify how the transaction flow goes through. Okay, first of all we will call the communicator of the layer 0 endpoint. So what exactly is a layer 0 endpoint? So layer 0 endpoint is nothing but a contract which is deployed to the native chain. In our case, the native chain is Ethereum because our app is deployed in this chain at present. A layer 0 endpoint is present in all the chain which it supports. And endpoint is nothing but a contract which is deployed. Okay, so the contract is deployed in the all the native chains it supports. So we will call the contract with passing the data of us. Okay, so we will pass the transaction. We'll just create the transaction. We will pass the destination chain ID, and the payload is nothing but the data which we want to pass. And the relayer asks, so what exactly is relayer? We'll see when it comes to the process of it. Okay, so just think of it. It's an oracle with the functioning of a different thing. Okay, it's just an oracle, but it functions differently than oracle. Okay, so here we pass our data to the layer 0 endpoint, and that layer 0 endpoint is called as communicator over here, which passes the data which we passed in the form of packets. Okay, it passes the destination address, and the payload is the data which you want to pass in. Okay, so please note that if you if you didn't watched our previous video, which was about another blockchain, another cross-chain communication framework provided. It's exactly a blockchain, which is called as Zeta Chain, which where we have explored completely about it along with the working live examples of smart contracts. If you haven't watched it, please do watch that so that you will get better understanding of this over here. Okay, referring to this here, it converts our data and payload into a packet. Packet is the data you can think of. Along with the data, it's a transaction which is being passed into the validator along with the relayer asks. Okay, relayer asks is to customize the relayer, which a normal developer may not be using it much. High-end applications like decentralized exchanges might be using it. Okay, so for us, what matters is the destination and the payload. Okay, it passes, so we create a transaction passing this data, calling a function. Okay, and it calls the communicator is nothing but an endpoint. It calls the validator is also an endpoint, which is in the native chain. Endpoint is nothing but its contract, and that validator, what it does is it passes the destination address of the our contract. Okay, so in this chain A is Ethereum and chain B is Matic. So in this case, chain A Ethereum, our contract is, let's say, 0EABC, and our contract in chain B also is 0EABC. Okay, so destination chain address will be 0EABC. 0EABC in the sense the last 4 to 5 characters of the chain contract address. Okay, so destination address will be passed along with these details to the network. Okay, network is also an endpoint created by the Layerzero. Okay, what happens is once it passes the destination to the network, along with that it passes packet. A packet is nothing but our destination and payload, combination of our destination and payload, and transaction and relayer asks to the relayer. So what exactly is relayer? Relayer is an oracle, what you can think of, which basically fetches the data from a blockchain. Okay, and oracle is, as you all know, Chainlink is an oracle which provides services which is the data off chain to on chain. Okay, if you don't know about is what is a chain link, you can just Google it. It's a very popular platform you can think of. Okay, the same as our endpoints. Okay, so it's an oracle. Currently, Layer0 uses Chainlink Oracle to provide us with at present it uses Google Cloud, but before this it used to use Chainlink protocol to provide data. Okay, so let's get into this. Okay, what it does is it passes this data to the relayer. Okay, what this relayer does is when this goes to the relayer, what this does is this fetches the proof. Okay, although it's 7, it happens simultaneously after this. Okay, once we send the transaction and the data which we want to pass it fetches the proof from chain A, which is the Ethereum, over here to it, and it stores in an off-chain database. Okay, relayer stores the data, which is nothing but a proof in an off-chain database. So after that, once it's stored, let's come to this part. So the network, after passing the packet to the layer, it passes destination address and current block ID. Current block ID, you can think of block header. Block header is nothing but what we see in our Explorer, right? That's the same thing. It uses Merkle tree proofing for transaction validation in the source chain, and so after that, once it passes it to Oracle, what it does is it fetches the block header from the chain. Chain is nothing but our Ethereum chain. It fetches the block header and passes the block header to the network. So you don't have to pass this to the this endpoint. Okay, this Oracle is in on chain, but the Layer0 service has created in such a way that it constantly watches these contracts to notice that if there is any transaction which involves cross-chain messaging. Okay, it constantly monitors this contract so that if there is any function which is called in which emits an event, it will be looking at it, and it starts processing all these things. Okay, so it first passes to the relayer fetches the proof will only be fetched once the transaction is successfully created on the source chain. Okay, and it stores it over here. After that, our network endpoint, which passes the destination and current block ID to the Oracle. Oracle fetches the block header from the chain A, which is Ethereum, and passes the block header to the network. So it don't have to pass the destination and current block ID, because in the block header itself, we will get all the details of the messages which we have to pass to the chain B, which is our mat. Okay, so we will get the block header block header of that. After that, what happens is this block header hash is passed to the validator of this chain, which is chain B. Okay, what happens once this block header is passed? This calls the relayer. Relayer is an off-chain service. Okay, relayer is not an on-chain. Okay, relayer is an off-chain. You can think of it as Google Cloud or maybe Oracle. Oracle even. Okay, Oracle in the sense Chainlink. So it calls the relayer passing the block header hash to get the details. Okay, we just passing the block header here. It gets the block header hash, which hash is nothing but irreversible string which you can think of. Okay, block header hash, it passes it to relayer, and what it gets is it gets a list of packet destinations and payloads and transaction proofs. Okay, if there is a single transaction, it will be a single packet with all these details. If there are multiple messages passed at the same time with multiple tabs, it will be passed as an array, as you can think of here. Okay, as you can see here, it will be passed as this to the validator in the chain B. Okay, so there is no here, this chain A and this chain B are not communicating together directly. Okay, using these two are independent entities, means that there is no single point of failure, means that they are working independently and there will not be any collisions to this. Okay, and as you can think, like these are kind of centralized because currently layer 0 uses Google Cloud, which is not decentralized. Okay, as you can think of, and after that it passes the data to the validator. What validator does is validator passes it to the communicator. Communicator is nothing but our endpoint. Okay, what happens in the communicator is communicator calls our function in the destination chain. Okay, if you please do refer our previous video on the zeta chain so that you can get to know clearly about what I'm talking here. Okay, so there I have cleared the concepts of how cross-chain communication works. Along with that, this is another type of the same architecture what you can think of. Okay, please do watch the previous video, the link will be in the description for sure. Okay, and what it does is it calls our function. So here we will have a send function, here a send function, here there will be receiver function. Okay, the communicator will call the receive function asking the destination address is not for us, like destination address for communicator to call this contact, and payload is the data which passes to this receive function. Okay, it passes payload the data to this receive function, wherein we will look into the computation part of how these transactions actually goes through and works. Okay, so this is it. So chain A calls this calls endpoint, calls an endpoints function, passes to validator, passes to network, passes to relayer, along with Oracle. Oracle fetches the block header, relayer fetches the proof, Oracle passes block header to network, validator calls the relayer with block header, getting the payload and the details of the messages which the developers, basically dApps, want to pass to the other chain. And the communicator, the validator will passing the packets, each one of the packets will pass to communicator, and communicator will call each one of the functions in the contract, which is a receive function. Okay, here all the integrity and everything security constraints are being maintained. Okay, here our applications will here we don't have to authenticate that whether it's called by our application itself, because it's all handled by our source chain contract. Okay, source chain contract and destination chain contract, where we specify who can call this receive functions. Okay, so it will pass this with the data which we passed in here. So if we let's say we passed a function passed the data called transfer 2000 DAI in chain A, which is Ethereum, to a user on the chain B. Okay, transfer 2000 DAI to user on the chain B. Okay, so what it does is it usually it burns or locks his DAI in this chain, and it passes the data here on receiving the data, like transfer 20,000 DAI to the user. It will mint, or basically there is no point of minting here. It will transfer those DAIs into the user account in the chain B. So the user don't have to like rely on centralized exchanges to transfer funds across multiple blockchains. And some of the popular projects using Layer 0 include Purji Penguins, DYDX, and many more. You can look at them using their community tab over here. And as you see, you can download their white paper over here and some of the funds over here. And you can join their huge Discord community by clicking on the link over here. Okay, and this was a deep dive on layer zero network and protocol which you can think of. So for more such informative videos like this on Web3 communities, make sure to like this video and subscribe to our channel. And let's meet in the next video. Till then, take care.